95% of the universe consists of dark matter and dark energy. But we don't know what they are. Time stops inside black holes. Some stars spin billions of times per second. And perhaps there are infinite parallel universes. No matter how advanced science becomes, the universe is still full of mysteries. Here are the universe's 10 most terrifying mysteries. 10. Dark matter. Everything we see in the universe, stars, planets, galaxies, these make up only 5% of the universe. So where is the remaining 95%? Scientists call this dark matter and dark energy, but we don't know what they are. We can't see dark matter. It doesn't emit light, doesn't reflect light, but we know it exists because it creates gravitational effects. It holds galaxies together. Galaxies rotate much faster than their visible matter allows. This means something invisible is affecting them. Scientists have been searching for dark matter for years. They conduct experiments with giant particle accelerators. They build huge detectors underground, but they still haven't found it. According to some theories, dark matter consists of new types of particles. Weakly interacting massive particles called WIMPs. According to other theories, it consists of primordial black holes, or perhaps exotic particles like gravitons, but none have been proven. We don't know what makes up most of the universe. This is one of science's greatest mysteries. Dark energy. There's something more mysterious than dark matter, dark energy. It makes up 70% of the universe, and it's expanding the universe at an accelerating rate. In 1998, two groups of scientists were observing distant supernovae. They discovered something shocking. The universe isn't just expanding, the expansion is accelerating. This was unexpected. Gravity should slow the universe's expansion, but the opposite was happening. Something was pushing the universe outward. Scientists call this dark energy, but what is this? The most popular theory is Einstein's cosmological constant, the energy of empty space, vacuum energy. According to quantum mechanics, empty space isn't actually empty. Virtual particles constantly appear and disappear. This creates energy. Perhaps dark energy is this, but mathematical calculations face a terrible problem. The vacuum energy predicted by quantum theory is 120 orders of magnitude larger than the observed dark energy. This is physics' worst prediction. There are other theories too. Perhaps dark energy changes over time. Perhaps there's a fifth force. Perhaps physics laws aren't the same everywhere in the universe. But there's no definitive answer. And if dark energy keeps strengthening, the universe's end could be terrifying. The Big Rip, everything will be torn apart. Galaxies, stars, planets, atoms, everything. The center of black holes. Black holes are cosmic objects where gravity is so strong that even light cannot escape. When giant stars die, they collapse and form black holes. But what's at the center of black holes? Scientists call this the singularity, an infinitely small point, infinite density. But this is a mathematical absurdity. Physics laws break down here. Einstein's general relativity theory works up to the black hole's event horizon, but it fails at the center. Quantum mechanics is also helpless. Because quantum mechanics works at very small scales, gravity is neglected. But at the black hole's center, there's both a very small scale and very strong gravity. The two theories conflict. What scientists need is a quantum gravity theory, like string theory, loop quantum gravity theory. But these haven't been proven yet. According to some theories, the singularity really exists. According to others, it doesn't. Perhaps there's quantum foam at the black hole's center. Perhaps a kind of quantum ball. Perhaps a gateway to another universe. White holes or wormholes. But these are speculative. What's certain, if you fall into a black hole, we don't know what will happen to you. Spaghettification? Time freezing? Transition to another dimension? Nobody knows. Double slit experiment and quantum mystery. Quantum mechanics is the physics theory that works at the universe's smallest scales. And it's completely insane. The double slit experiment shows this. You pass electrons through two slits in a wall. There's a screen behind. The electrons create a pattern on the screen. If you don't observe the electrons, an interference pattern forms. This means electrons behave like waves. They pass through both slits simultaneously. But if you observe which slit they pass through, the pattern changes. Now they behave like particles. They pass through only one slit. Observation changes reality. How can this be? The most popular interpretation is the Copenhagen interpretation. Before observation, the electron exists in both states simultaneously. Superposition. When observation is made, the wave function collapses. One state becomes real. But this is illogical. Isn't the moon there when you're not observing it? Einstein didn't accept this. God does not play dice, he said. But quantum mechanics proved correct. There are other interpretations too. The many worlds interpretation. At each measurement, the universe splits in two. In one universe, the electron passes through the right slit, in the other from the left. Infinite parallel universes. Or pilot wave theory. Electrons are really particles but guided by an invisible wave. But which is correct? We don't know. Quantum mechanics works, but we don't understand it. The Fermi Paradox. There are 200 billion stars in the Milky Way galaxy. Trillions of planets. There should be billions of habitable planets. So where are the aliens? This is called the Fermi Paradox. Enrico Fermi asked in 1950, where is everybody? If life in space is so probable, why haven't we found any evidence? There are several explanations. Perhaps life is very rare. Perhaps Earth is truly special. Perhaps life's beginning is incredibly difficult. Perhaps complex life's evolution is very difficult. Perhaps intelligent life is very rare. Perhaps technological civilizations destroy themselves. Nuclear war, climate crisis, artificial intelligence. Perhaps there's the Great Filter, an evolutionary wall that most civilizations can't pass. Perhaps we haven't reached that wall yet. Or perhaps we've passed it and are lucky. Perhaps aliens exist, but we can't communicate. They're too far away. Speed of light limit. Specific time window. Perhaps their technology is very different from ours. Perhaps they're ignoring us. The zoo hypothesis. They're observing us but not interfering. Or perhaps we're in a simulation. The matrix hypothesis. Perhaps the darkest explanation. Silence because there's nobody. Perhaps we're truly alone in the universe. This is both exciting and terrifying. Why does time flow in one direction? Time only flows forward. We remember the past but can't see the future. Eggs break but don't spontaneously reassemble. Coffee cools, doesn't heat. Why? Physics laws are time symmetric. Newton's laws, Maxwell's equations, even Einstein's relativity theory, all work the same forward and backward in time, but thermodynamics' second law is different. Entropy always increases. Disorder increases. This creates time zero. But why? Initially, the universe had very low entropy. The Big Bang, everything was ordered. Then it expanded and entropy increased. But why was the beginning low entropy? This can't be explained. According to some physicists, time is an illusion. Like Carlo Rovelli. In quantum gravity theory, there's no time. Only change exists, events exist. Time's flow is our perception. Our brain puts events in order, creates memory, and creates the sensation of time. Other theories are crazier. Perhaps time really flows both directions. In a parallel universe, time flows backward. Or perhaps the universe is cyclical. Big Bang expansion, Big Crunch, Big Bang again. Infinite cycle. But these are speculative. What's certain, we don't fully understand why time flows forward. Why past and future are different. The measurement problem. One of quantum mechanics' greatest mysteries, the measurement problem. Quantum particles can be in superposition, in multiple states simultaneously. But when you make a measurement, the wave function collapses. One state becomes real, but how? When? Why? Schrödinger's cat shows this. A cat in a closed box. There's a radioactive atom in the box. If the atom decays, poison is released and the cat dies. If it doesn't decay, the cat lives. According to quantum mechanics, before opening the box, the atom is both decayed and not decayed. Superposition. So the cat is both alive and dead. But when you open the box, you see only one state, either alive or dead. The wave function has collapsed. But when did it collapse? When you opened the box? At the atom's decay moment? When poison was released? When the cat died? Or when consciousness entered? According to the Copenhagen interpretation, observation collapses it. But what does observation mean? Is consciousness necessary? Or is any interaction sufficient? According to the many worlds interpretation, there's no collapse. Every possibility becomes real in a different universe. In one universe, the cat is alive, in another dead. Both are real. Decoherence theory is another explanation. Environmental interaction destroys superposition. But it's not a complete explanation. The measurement problem hasn't been solved. And this questions quantum mechanics' foundations. 3. The nature of consciousness. What is consciousness? Why do we experience things? Why aren't we in darkness but within subjective experience? This is known as the hard problem. As philosopher David Chalmers puts it, there are easy problems. How the brain processes information, how it produces behavior. These are difficult but solvable. But the hard problem is different. Why do these processes create subjective experience? Why does seeing red feel like something? Why do we feel pain? Some say consciousness is a property of the brain. Neural activity. A sufficiently complex system produces consciousness. Integrated information theory formalizes this. But this isn't satisfying, because it doesn't explain why neural activity creates experience. Some say consciousness is fundamental. Panpsychism. Everything has a kind of consciousness, even electrons, atoms. Human consciousness is their combination, but this is speculative. Some say consciousness is an illusion. Like Daniel Dennett, there's no really subjective experience, just the brain's way of perceiving itself. But this is counterintuitive, because we can't deny experience. Cogito ergo sum. I think therefore I am. There are quantum theories. Roger Penrose's theory. Consciousness arises from quantum processes. Quantum collapses in microtubules. But there's no evidence. Perhaps consciousness is unsolvable. Perhaps human intelligence is insufficient to understand its own consciousness. Perhaps higher intelligence is needed. Or perhaps consciousness will truly remain mysterious. The universe's final mystery. The information paradox. Stephen Hawking discovered something shocking in 1974. Black holes evaporate. Hawking radiation. Due to quantum effects, black holes emit particles. Very slowly, but they emit. After billions of years, the black hole will completely evaporate. But this encounters a problem. The information paradox. According to quantum mechanics, information is conserved, cannot be destroyed. But if you drop something into a black hole, its information is lost. It passes beyond the event horizon. And if the black hole evaporates, what happens to the information? Hawking radiation is completely random, doesn't carry the information inside, so information has been destroyed. But this violates quantum mechanics. Hawking initially said information is destroyed, but later changed his mind. Perhaps information is encoded in Hawking radiation. But how? The holographic principle is one explanation. Information is encoded on the black hole's surface, at the event horizon, and as radiation is emitted, information is also emitted. But details are unclear. The firewall paradox is another problem. If information is conserved, there must be an energy wall at the event horizon. But this contradicts relativity theory, because the event horizon isn't a special place. Someone falling shouldn't notice anything. Which solution is correct? ER equals EPR proposal. Wormholes and quantum entanglement are the same thing. Perhaps information passes through the wormhole. But these are still theoretical. The information paradox hasn't been solved. What was before the Big Bang? 13.8 billion years ago, the universe exploded from an infinitely small, infinitely hot point. The Big Bang, space, time, matter, energy, all began at that moment. But what was before? Some say this question is meaningless. Like Stephen Hawking, because time began at the Big Bang, there's no before. What does going south of the South Pole mean is what before the Big Bang means. But this isn't satisfying. There are other theories. Cyclic universe. Roger Penrose's conformal cyclic cosmology. The universe expands, then contracts, then explodes again. Infinite cycle. The previous universe's end is our beginning. Colliding brains theory comes from string theory. Our universe is a brain. We live on a higher dimensional membrane. There are other brains. Sometimes they collide, and the collision creates the Big Bang. Quantum foam. At Planck scale, space-time is foamy. Virtual universes constantly form and disappear. Ours survived. Chance. Multiverse. There are infinite universes, all with different physics laws. Ours is suitable for life. Anthropic principle. But these are speculative. What's certain, we don't know before the Big Bang. Perhaps we'll never know. Because information can't come from beyond that moment. Cosmic event horizon. The universe's greatest mystery. These 10 mysteries show how mysterious the universe is. Science has advanced greatly, but there's still much we don't know. Perhaps some answers will be found in the future. Perhaps quantum gravity theory will develop. Perhaps new telescopes will find aliens. But perhaps some questions will remain unanswered forever. The universe will continue to amaze us.